Hello students, I am Swati Ghadge, Assistant Professor, Department of Civil Engineering from Walchand Institute of Technology, Solapur. Topic for today's session, Practice Numerical on D'Alembert's Principle. Learning outcome. At the end of this session, learner will be able to analyze the body which is in motion by using dynamic equilibrium equation discovered by D'Alembert. D'Alembert principle is system of forces acting on a moving body is in dynamic equilibrium with inertia force or reverse effective force of the body. Hence, just by applying a reverse effective force, the moving body can be treated as a body in equilibrium and can be analyzed using equation of static equilibrium. Consider a numerical. Determine the constant force P shown in the figure that will give the system of bodies of velocity 3 meter per second after moving a distance of 4.5 meter from the position of rest. Coefficient of friction at all contact points is 0.2. Assume pulleys are frictionless. So let us understand the given numerical first. There are three weights. The weight of first block is 250 Newton, the weight of second block is 1000 Newton and third block is 500 Newton. It is connected by a rope. Rope is passing over a pulley. At the one end of the rope, the pulling force P attached over here. Question is determine the P for the targeted velocity 3 meter per second. Coefficient of friction for contact surfaces is given 0.2. And displacement is given, that is 4.5 meter. Now, how to determine the P by using D'Alembert principle, we will see now. First, we will draw the free body diagram for the individual blocks. For that, remove support and separate it from all the connected bodies. So, after removing support and after removing the connection with other body, it will be like this. After removing, replacement of connectivity with the other body, instead of that, show the forces. So that it will be in equilibrium under the action of this force. Self weight will show it by force, that is vertically downward. So this is the self weight. Now we have removed the support also. So instead of support, normal reaction will be there. There is a tension in the cable. So here say it is T1. It is a one cable or one thread passing over a pulley. So same tension will be there. So both will be T1. Similarly here, this is the same thread, so same tension will be passed through this thread, so it will be T2. We have removed support of each block, so instead of support, show support reaction, and the blocks are moving with the pulling force P, so shows frictional force in the opposite direction of the motion. So for the block 1, N1 and F1 will act like this. For the block 2, N1 and F2 will act like this shown in the figure, and for the block 3, this is N3 and F3. The direction of motion for the first block, direction of motion is horizontal. For the second block, direction of motion is upward side, and this is the direction of third block, that is 500 Newton block. In the opposite direction of motion, inertia force will act. So according to D'Alembert principle, show inertia force or consider inertia force in the opposite direction of motion. So for the first block, it will be M1A. M1 is the mass of the first block. For second block, it will be M2A, and for the third block, it is M3A. So this is the free body diagram of individual block. This is free body diagram of 250 Newton block. This is free body diagram of 1000 Newton block. and this is for 500 Newton block. So free body diagram is we have completed. So before analysis, we have to determine the acceleration. So acceleration, we have given data with us that body start from the rest. So initial velocity is 0. Targeted velocity is 3 meter per second. So it is final velocity. Displacement is given 4.5 meter. So we will use linear motion equation, that is v square is equal to u square plus twice as, and we'll determine the acceleration. So acceleration is 1 meter per second square. Now consider figure number 4 for the analysis first, because here only one unknown is there, that is T2. So use first equation, summation of Fy is equal to 0. So N3 is 500 Newton. By using summation of Fy equation, we will get N3 is equal to 500 Newton. Then the relation between normal and frictional force is F is equal to mu into N. So we will determine F3. F3 is equal to 0.2 into 500, that is 100. Now find out M3A, that is MA force. So it is 1 into 500 divided by 9.81. That is weight divided by gravity is M. It is 50.968. Now go for the second equilibrium equation, that is summation of horizontal forces is 0, and determine T2. So T2 is F3 plus M3A. See here in horizontal direction only 3 forces are there, T2, F3 and M3A. So we have considered all these 3 forces, determine T2. So T2 is 150.968. Now consider second block for the analysis, that is 1000 Newton block. This block is on the inclined plane. So for the analysis of such a block, we have to consider x and y axis in the inclined plane, in the direction of plane and in the perpendicular to the plane. So these are the axes shown over here. Here you see that T2 force is in the x direction, T1 force is also in x direction, F2 is also in x direction, N2 is in y direction, that MA force is in x direction. Only 1000 force is there which is not in x and y direction. So we will resolve that force in x and y direction. For that we need theta for the resolution. So theta is, here the slope of this line is given in the numerical itself, it is 4/3. So theta is tan inverse of 4/3, it is 53.130. So this is theta. Now this plane is making theta with horizontal. So this perpendicular plane, that is y axis, will make theta with vertical. So that angle will be theta. So this will be theta. So now it is very easy to resolve 1000 Newton force with this theta. So the direction adjacent to theta will be cos and the opposite will be sine. So this is the adjacent side, so it is cos, and this is opposite side, so it is sine. So 1000 into cos theta is 600 and 1000 into sine theta is 800. So we have determined the component, x and y component of 1000 Newton. I hope you understand this resolution. Later, solve it by using equilibrium equation. We can consider equilibrium equation because we have added the MA force as per the D'Alembert principle. Now go for the equilibrium equation and find out the T1 force. So for the T1 force, first we will consider the summation of vertical forces is 0. So in y direction only 600 and N2, these 2 forces are there. So N2 is equal to 600 Newton. Therefore F2 is equal to mu into N2 is 120. Now go for the second equilibrium equation. Before that, find out MA force. So MA is M2A. M2 is 1000 divided by 9.81 and 1 is acceleration. So it is 101.936. Now use summation Fx because all the forces in x direction now known to us except T1. So T1 is equal to T2 plus MA plus F2. So you put all the values of F2, M2A and T2 here and determine T1. So we'll get T1 372.904. Now consider 250 Newton block for the analysis. Here we will get the P, our targeted parameter, that is we have to determine the P in this equation. Now first consider summation of Fy is equal to 0. So in y direction only two forces are there, 250 Newton and N1. So N1 is 250 Newton. Therefore F1 is mu into N1 is 50. Now find out MA force, that is M1A. So it is 250 divided by 9.81 into 1. It is 25.484. Now go for the summation of Fx, that is summation of horizontal forces is equal to 0. In x direction there are four forces, P, F1, T1 and MA force. So P is equal to T1 plus F1 plus MA force. So put all the values here in the equation. We'll get P is equal to 448.39 Newton. Now here one review question is there. For this given figure number 5, see here you can see these three blocks are there, 200 Newton, 40 Newton and the 60 Newton. And it is arranged with the help of these pulleys like this shown in the figure. You choose a correct free body diagram of three weights shown in the figure 5. So here there are four options, option A, option B, C and D. You choose a correct set of free body diagram for this given numerical. Think and select a correct answer. In the red color arrow, MA force is shown to you. So it's simply you have to decide in which direction MA force will act. The correct option is option B. Let's see why. Because this 2000 Newton force will move downward because it is heavier than the other block. So as it will move downward, so inertia force will act in the opposite direction of motion, that is upward. Now by considering these two forces, 60 and 40 Newton, 60 is heavier than the 40 Newton. So 60 will move downward and 40 will move upward. So this is the direction of motion. In the against, MA will act in the opposite direction. So that MA force for the 60 Newton block will act in upward direction and MA force for the 40 Newton block will act in downward direction. So option B is the correct free body diagram set for this given numerical. These are my references. Thank you very much for the watching video.